Today in the workshop, we'll be building a surveillance system using a Raspberry Pi and a product called motionEyeOS. We'll take a look at a number of Raspberry Pi cameras, and then we'll see how motionEyeOS works and how to configure it with both a Raspberry Pi 3 and a Raspberry Pi Zero W. We're under surveillance today, so welcome to the workshop. Hello and welcome to the workshop. Today I've got a Raspberry Pi project for you. We're going to take a Raspberry Pi plus a Raspberry Pi camera and build a surveillance system. Now our surveillance system is going to have some sophisticated features. It's going to have motion activation. It'll be able to record both video, still pictures, time-lapse pictures. It will be able to do things like send you an email alert when it detects motion, and you'll be able to use one or several of these in your home and monitor them all from the same web-based interface. And that web-based interface will look just as nice on your desktop as it does on your tablet or your phone. Now this may sound like a very sophisticated and complicated project, but actually it is not, thanks to a product called motionEyeOS. motionEyeOS is an image that you can get for the Raspberry Pi as well as a number of other single board computers, and using motionEyeOS you can build a very sophisticated surveillance system. Now today what I'm going to do is I'm going to show you how motionEyeOS works, and I'm going to set it up on both a Raspberry Pi 3B Plus and a Raspberry Pi Zero W, and those, as of this recording time, are kind of the opposite ends of the Raspberry Pi spectrum, from the most powerful Raspberry Pi to the least powerful one. Before I do that, however, I wanted to start discussing Raspberry Pi cameras, so let's go and do that right now. So let's take a look at the Raspberry Pi camera. The Raspberry Pi camera can be used for still pictures and for video. The camera connects to the Raspberry Pi using a CSI connector. The camera is capable of 1080p video at 30 frames per second. It's available in visible and infrared light versions. There are 2 official models of the camera, plus several clones. Version 1 of the camera was released in 2013. This version uses the OmniVision OV5647 sensor. It has a 5 megapixel still resolution. The pixel sensor resolution is 2562 by 1944. Version 2 of the camera was released in 2016. Version 2 uses a Sony IMX219 sensor. It has an 8 megapixel still resolution. It has a 3280 by 2464 pixel sensor resolution. The Raspberry Pi boards have a camera serial interface Type 2 or CSI-2 connector. They use a 15-pin zero insertion force connector for the camera. The camera is connected to the Pis using a ribbon cable. The Raspberry Pi Zero and Zero W use a smaller connector for the camera. Here's the location of the camera CSI connector on the Raspberry Pi 3 and the Raspberry Pi 2 boards. And here is the connection of the CSI connector on the Raspberry Pi Zero boards. Now let's take a look at some Raspberry Pi cameras. Now here are a couple of different Raspberry Pi cameras I wanted to show you, along with a couple of cables to connect them to the Raspberry Pi CSI connector. Now the first camera I have here was the original model, the Model 1. And as you can see, when the camera comes from the factory, it's got a little sticker over the lens, so you'll need to, of course, peel that off before you use it. But essentially, it consists of a camera module on one side and some supporting electronics on the other side, as well as a connector for the zero insertion force, or ZIF or ZIF if you prefer, socket. And that's where you take this ribbon cable to connect to the camera serial interface, the CSI connector, on the Raspberry Pi. Now, you can get ribbon cables in different sizes. I've got one over here to show you. This is quite a very long one, so if you need to locate the camera a fair distance from the Pi, you can do that. Now, the next camera I want to show you over here is this one over here. This is the Raspberry Pi NOIR camera, which means no infrared, but I also love the name because I can't help but notice that NOIR also spells noir, which of course is the French word for black. And again, it looks very similar to the other camera. Now, I've got this one mounted on a little holder. It wasn't included with the camera, but you can pick these up and they're a good way to mount your Raspberry Pi cameras. Now, this camera came with a really neat accessory, this little disc. And what the disc is for is you place it on front of the camera here and you rotate it, and what you can do is you can use this to actually focus the camera lens. The lens can be rotated and you can adjust the focus. If you don't have a disc like this, you can probably do the same job if you're very careful using some needle nose pliers. Now, when you're using the Raspberry Pi Zero, there's one additional concern. The Pi Zero has a CSI connector, which is a lot smaller than the one on the other Raspberry Pis. The CSI connector is a small one like this, so you can use an adapter cable like this to convert a camera like this one for use with the Raspberry Pi Zero. Here's a Pi Zero camera. This one has already been configured with an adapter cable, so it came from the factory like that, and it's ready to plug into a Pi Zero. And finally, I wanted to show you this little camera. This is not one of the official Raspberry Pi cameras, but I absolutely love this. This is for the Pi Zero again, and as you can see, it's extraordinarily tiny. What they have done is they've taken the camera module and they have it separated, and they use a piece of flexible printed circuit board and they put the supporting electronics right on the board, and then it has the connector that plugs into the Pi Zero CSI connector. And so if you're trying to make a very, very tiny Raspberry Pi camera that is self-contained, using a Pi Zero and one of these cameras would be absolutely awesome for that. So there you go, a few cameras you can use with the motionEyeOS project. So now that we've looked at a number of Raspberry Pi cameras, it's time to focus our attention on motionEyeOS. So let's learn what motionEyeOS is, and then I'll show you how you can get a copy of the image to load onto your Raspberry Pi. So what exactly is motionEyeOS? motionEyeOS is a product that turns a Linux single-board computer into a video surveillance system. It uses two open-source products, the Motion backend and the motionEye frontend. motionEyeOS itself is an open-source product whose code is available on GitHub. There are builds available for several single-board computers. Here are some of the single-board computers supported by motionEyeOS. motionEyeOS is available as an image file. The product is plug and play when you use a wired Ethernet single-board computer. You can also configure it for Wi-Fi access. A single-board computer running motionEyeOS can run unattended. motionEyeOS provides a web-based interface which is both mobile and tablet friendly. Both the Raspberry Pi and USB-type cameras are supported. It's capable of motion detection along with email notifications. motionEyeOS can do time-lapse movies. Video and images can be stored on the SD card, on your LAN, or by using cloud storage. So let's start working with motionEyeOS. Now, in order to use motionEyeOS with your Raspberry Pi or any single board computer, you're going to need to get an image file and burn it onto a micro SD card. So your first step is to go and visit the motionEyeOS wiki on GitHub, and I'll have a link to that in the article accompanying this video. When you're on the home page of the wiki, scroll down and go to where it says check out the list of supported devices. Now, I've got this open in another tab over here. Now, this lists all the supported devices that motionEyeOS is currently capable of running on. And if we scroll down the list, we'll see a number of Raspberry Pi images. Now, you need to grab the correct image for the model of Pi that you're using. So pay attention to what these images are for. For example, if you have a 0 or 0W, you will want to grab this particular image. If you have a 2, you're going to grab this one. And for a Raspberry Pi 3, you will be grabbing this image. So click on the image or images that you wish to download and download them to your local computer. Once you've done that, you're going to need to burn these images onto a micro SD card, and I use an application called Etcher for that. Now, those of you who've seen my previous Raspberry Pi videos have probably seen me use Etcher before. If not, this is free software that you can get at etcher.io, and it's available for Linux, which I'm running it on right now. It's also available for Windows and for the Mac, so it's a great application. The beauty of Etcher is that it is a very intelligent program, and it won't let you do something like accidentally burn that image onto an external hard drive or something, which would really ruin your day. So that's one of the things I like about Etcher. It's also very simple to use. You basically select the image you want to get. So let's select this particular image here, the Raspberry Pi 3. As you notice, I've downloaded a number of them. And then it prompts you for the storage device, but it's actually already selected the correct storage device. You can change it if you wish, but you'll seldom have to do that. And then you simply hit the flash button. Now, as I'm running Linux, I have to authenticate this with my password first. So I'll do that, and Etcher will start. And it displays the progress of the flashing right over here on the button. So let's let this flash. After Etcher completes the flash, it'll go through a validation step to make certain that the data on the micro SD is okay. And there we go. Etcher has finished flashing our micro SD card. Now, it does give us an option to flash another micro SD card with the same image if you want. So if you've got several of the same Raspberry Pi boards that you want to install motionEyeOS on, you can go ahead and stick another micro SD card into your reader and flash that one. But once you've got your micro SD card, we are now ready to use it on the Raspberry Pi. So now that you've got a copy of motionEyeOS, I'm sure you're anxious to get started with it and use it with the Raspberry Pi. But before I do that, I thought it might be a good idea to test out the Raspberry Pi camera, just to make certain that it was working. And in order to do that, I'm going to use Raspbian. Now, Raspbian is the default operating system for the Raspberry Pi. There are other OSs you can run on the Pi, but most of us run Raspbian. You can get a copy of Raspbian on the Raspberry Pi website. It can be downloaded as an image file, which again you can use Etcher to burn onto a micro SD card. Once you've done that, insert the micro SD card into your Raspberry Pi. Also connect a keyboard, a mouse, and a video monitor up to the Raspberry Pi as well, because you're going to need to use the Raspbian desktop. So you do that with a camera hooked up. You can quickly test the camera and make sure everything is working. So we're going to go ahead and do that right now. So for my camera test, I've set things up as follows. I've got my Raspberry Pi with the camera plugged into it. Now, when you plug the camera into the CSI port, you need to orient the cable in the correct direction. If you put it in backwards, you're not going to hurt anything, but it simply won't work. And when you pull up the ZIF or ZIF connector, if you wish, you will see that the contacts are on one side. In this case, the contacts are on the side that is facing the HDMI port on the Pi 3. And so that's the side that you want to put the cable contacts onto. And you just insert the cable in there and then press down on the ZIF connector, and that'll secure the cable in. Now, once we've got the cable in, of course, we want to test the camera, which is the whole purpose of this exercise over here. So I've got Raspbian right now inside my Raspberry Pi. And so what we'll do is we'll boot up Raspbian over here. And the Raspberry Pi is booting. Now, if this is the first time that you've run Raspbian, it'll actually do 2 reboots, as it has to resize the SD card. And then it's going to prompt you through a series of questions asking you about your locale, the type of keyboard you're using, etc. I've already set up my Raspbian, so it just goes to the Raspbian desktop. Now, one thing you're going to need to do before the camera test is you're going to go down into Preferences. Under Preferences, go to Raspberry Pi Configuration. In Configuration, go to the Interfaces tab. Now, by default, everything here is disabled, but you're going to need to at least enable the camera. If you want to enable some of the other features, you're quite welcome to do so, but make sure that you at least enable the camera, and then hit OK. When you do that, you're going to need to reboot the Pi. So reboot and join me back over here once it's booted up. So once the camera interface has been enabled, we can do a very quick test, and we're going to do this with the Raspberry Pi command line. So we'll go to our command line over here, and we're going to type the following: RASPISTILL, then a space and a -V, and then a space and a -O, all lowercase, and then a space and the name of a file. I've called mine test.jpg, but you can call it whatever you like. Just make sure you end it with .jpg. And then hit enter. And you should see the camera in video mode for a while, and you can see some guy with a smiling face over here. It'll stop and go back to the command prompt, and we can close this right now. Now let's just go into our file manager. And we see a test.jpg file, which we just created. So if we click on it, we can see a picture of this handsome guy over here. And so this proves to us that our Raspberry Pi camera is working. So now that the Pi camera is working, and we've confirmed that, we can shut this down, and we can start working with motionEyeOS. So now that we've determined that our Raspberry Pi camera is working, it's time to actually use motionEyeOS. So what I've done is I've shut down Raspbian, I've removed the micro SD card that held Raspbian, and I've replaced it with the micro SD card with the image of motionEyeOS for my board. Now in this case I'm using a Raspberry Pi 3B+, so I've used the Raspberry Pi 3 image. Now one important thing to note is that I've connected my Raspberry Pi to my network using an Ethernet cable. In other words, this is a wired connection. And this is important to note because there is another step we would have to use a wireless connection, such as the one we're going to need when we use a Raspberry Pi 0W. So this is a wired Ethernet connection. Another thing I have done is I've connected an HDMI monitor onto it. Actually, I just haven't removed the monitor from my last experiment. The keyboard and mouse are not necessary because there's nothing you can do with it, and it isn't actually necessary for you to connect a monitor, but by connecting a monitor, we'll be able to determine the IP address very easily of our board. Now, if you don't have a video monitor, or if you have the camera in a location that is simply impractical to connect a video monitor, don't worry, I will show you how you can determine this without using a monitor. But let's take a look at what happens when I boot up motionEyeOS the first time on my Raspberry Pi 3. So let's boot up the motionEyeOS. So as you can see, it uses a Raspbian boot. You can notice the 4 raspberries at the top. And it loads a number of modules. Now the first time you boot this up, it'll also take some time to format the SD card. I've already done that before. And then it finishes booting. Now at this point, the most important piece of information you can garner from this is the IP address. So in this case, I've been assigned an IP address of 192.168.1.100. So I'm going to note that number, and then we're going to go and take a look at the motionEyeOS camera. So here I've gone with a web browser, and I've gone to the same IP address. So you'll notice that I've typed it up over here, 192.168.1.100. Of course, when you do this, you may have a different IP address. So just type that in. And this is the motionEyeOS screen. So you can see my camera over here, and it's a streaming video at a relatively slow frame rate, which is pretty typical of surveillance cameras. And it's giving a relatively reasonable picture. Now, there's a couple of things I can do right now. By default, you've logged in just as a user, but you can log in as an administrator. First, I'll show you what you see as a user. As a user, you can set the number of columns and rows, etc. And that really doesn't apply unless you've got more than one motionEyeOS camera. And as I'm going to show you later, you can have multiple cameras on the same screen. Now, what I'd really like to do, though, is log in as an administrator. So hit the switch user, which is this icon over here. And you will get a login screen. Now, by default, the login is simply admin with no password. So hit that and hit login. And we're presented with the same image, only now when we go into the side here, onto settings, you'll see you have a number of other options over here. And I'm going to go through some of these options with you in a moment, but first I need to discuss a few other aspects of motionEyeOS with you. Now, as you've seen, motionEyeOS presents a very nice interface on a web browser that you can use from anywhere in your network. And although I showed it to you on a desktop, it also formats itself very well for tablets and for phones. Now, the only thing you needed to know to look at this camera was its IP address. And since I had a video monitor attached to my Raspberry Pi, I was able to see the IP address on boot up. There may be situations, however, in which it's impractical to connect an HDMI monitor up to the Raspberry Pi, and you still need to know that IP address. Now, there's a number of ways that you can get that. If you're using Microsoft Windows, it's possible that if you look in your file manager under your network, you may even see the camera, and this sort of depends on how your network has been configured in the first place. However, the easiest way to do this is by using something called an IP port scanner. So I'm going to show you a free IP port scanner that's available for Windows, Mac, and Linux called Angry IP Scanner. And we're going to use that to determine the IP address of my motionEyeOS camera. Now here's the interface for the Angry IP Scanner. I'm running this under Linux, but the interface for Windows and the Mac looks pretty well the same. Now this is very easy to use. It's already pre-selected a range of addresses to scan, and it matches the range of my network. And this should actually set itself up correctly for your own network. So these numbers may be a bit different depending on how your network's configured. After that, all you need to do is hit the start button. And as you can see, the scan starts. And it goes through every IP address in the range and looks for a device that is on that address. Now let's let the scan finish. And it says scanning is complete. And it's found 18 active hosts right now. Keep in mind that you may have more computers and devices on your network, but if they aren't turned on at the moment, they won't appear on the list. Now let's scan down over here, and here we have some devices. And note over here that I have a device who has a name of MEYE. That is typical of the motionEyeOS devices. They all start with MEYE and then they have a unique number, and it'll give me an IP address over here for this device. If you have multiple cameras, you'll look for several of them with this pattern, and you can get their IP address off of this. So this is how you determine an IP address using the Angry IP scanner. Now, those of you with a keen eye will probably have noticed that the IP address of my motionEyeOS server has changed. Initially, when I used it, it was 192.168.1.100. Now it's .1.102. So what's going on over here? Well, what's going on is something called DHCP. DHCP stands for Dynamic Host Control Protocol, and this is a mechanism used on a TCP/IP network to dish out IP addresses to new machines that are joining the network. In your router is a component called a DHCP server, and the DHCP server is responsible for dishing out these IP addresses. Your router will be configured with a number of reserved addresses that are reserved for DHCP. So when a new machine comes on the network, it sends a request out to the DHCP server. The DHCP server says, okay, I've got a free IP address over here, and it dishes that one out to the machine. Now, as long as the machine stays powered on the network, it's going to stay the same IP address because DHCP addresses have what's called a lease period. They expire after a while. When a machine is on the network, it realizes that its lease is about to expire, and it sends out a renew request so it can keep that same IP address. However, if you turn off the machine and don't turn it back on for a while, the lease will expire, and the next time it connects, it could very well get a different IP address. And this is exactly what happened to my motionEyeOS camera. I turned it off for a while. When I turned it back on, it got assigned a different IP address. Now, for computers and tablets and things, this really isn't a problem, but if you're using a server, and motionEyeOS is a server, it's a video server, this becomes a real annoyance. After all, I had to set my web browser to the IP address of the motionEyeOS server, and if that keeps changing, it means every time I want to use my camera, I have to go and find out what the new IP address is and set my web browser accordingly. So much for bookmarking it and everything. If I have a lot of motionEyeOS cameras, this could be a real nightmare. So the solution for this is to assign a fixed IP address to your motionEyeOS server. Now, before you assign a fixed IP address to the motionEyeOS server, you're going to need to know what addresses are actually available. So you'll need to know what addresses are used in your DHCP pool. The best way of finding out this is to log into your router configuration and take a look at what range of addresses have been assigned to DHCP. But if you can't do that for some reason, you don't have access to the router config, you could use something like the Angry IP scanner that we used and just make an educated guess. For example, in my network, you could see that most of the machines were all grouped within a certain range, and those are in my DHCP range. So I know that all the addresses lower than 192.168.1.100 on my network are available to assign fixed IP addresses to. So I'm going to show you how you can assign a fixed IP address to your motionEyeOS server now. So here I am back on my motionEyeOS screen on my web browser. You'll notice that I've changed my IP address to match the new IP address that my motionEyeOS camera has. And as you can see, it's working and giving us a wonderful view of my chest and the bottom of my chin. Now, I'm logged in as administrator right now. If you recall, you log in as admin with no password by default. If you're not logged in as admin, you need to click this little icon over here for switch user and use the login screen that comes up to type in admin. Again, no password is the default. After that, click this button over here for the settings. Now you'll see a number of settings. We took a brief look at this earlier. What I'm going to do here first under general settings is set advanced settings to on. And now that I've set advanced settings to on, as you can see, I get a number of other selections. Now we're going to look at a few more of these in a bit. Obviously, one that you'll probably want to work with is the admin username and password. But I'm not going to change that right now just for demo purposes, but I strongly recommend that you do end up changing this. What I really want to show you over here is this thing that says network. And under network, my IP configuration currently is automatic DHCP. Now, I want to set a fixed IP address, so I'm going to set it to manual static IP. And I'm going to get a couple of things that came up over here. Now, it's already suggesting a network mask and a default gateway, and these figures are absolutely correct. You don't need to change them, but this IP address I don't like because although it suggested a new IP address, it's within the range of my DHCP pool, and I don't want that. So I'm going to say 192.168.1, and I'm going to move this down to a range that I know is not in my DHCP pool. So I'm going to pick 80 for this particular one, and that just happens to be because 80 is, again, on my network, unused and not assigned to the DHCP pool. Once I've done that, I can click Apply. And it says it'll reboot the system, and I'm going to say yes. Now, of course, after the system reboots, I'm going to need to log in on the new IP address because the old IP address is no longer valid. So the system is rebooting right now. And so now I'm logging in under the new IP address. And as you can see now, my camera IP address is 192.168.1.80 as I set it. And if I were to reboot, power it down, and power it up again, I would still retain the same IP address. And then I can go and bookmark this address in my web browser for future use. So now that we've seen how motionEyeOS works on the Raspberry Pi 3 Plus, I wanted to show you how to use it with a Raspberry Pi Zero W. Now the Zero W is a very attractive little microcomputer. It only costs $10 US, and it comes complete with both Bluetooth and Wi-Fi. It does not, however, have a wired Ethernet connection, so the only network connection we can use is Wi-Fi, and there are some additional concerns when you use Wi-Fi with motionEyeOS, and I want to show you those right now. So let's go ahead and take a look at that. So I've connected up a Raspberry Pi Zero W. You'll notice that I've also left my Raspberry Pi 3 connected and running. I'm doing this intentionally because I eventually want to show you how you can use multiple cameras. Now for the Zero W, I've inserted the image file that I've burned onto a micro SD card, and it's inside the socket over here. And I've also, of course, attached a camera to it using the correct cable for the Zero W. Now, when you attach the camera to the Zero W, you want to make certain that the contacts on the cable are facing down toward the board. And again, you can use Raspbian to test out the camera if you want to make certain that your camera is working. Now, I haven't done anything special to this, and I want to show you what happens when I boot up the Raspberry Pi Zero W. So let's go and power this up right now and give it a boot. So as you can see, it starts off with a Raspbian screen. Now the first time you boot, formatting data partition is common. It just needs to format the rest of the micro SD card as a data partition. And this, by the way, is where it will store images and movies that you record by default. Okay, now it's done that. Now it's loading a number of modules, as it did before. Now here is where it gets interesting. It can't find a wired network, and it has stopped motionEyeOS. And of course it can't find a wired network because we don't have a wired network. The Raspberry Pi Zero W doesn't connect to one. So it's going to reboot and continue this over and over again. So we need to resolve this problem, and I'll show you how to do that right now. In order to make the Raspberry Pi Zero or any Raspberry Pi using Wi-Fi connect to the network, you are going to need to supply motionEyeOS with your network login credentials. You do this by creating a small text file and naming the file WPA_supplicant.conf. That's SUPPLICANT. It has to be all lowercase, by the way. You can't use mixed case in this file name. Now, the contents of the file are as follows. This is a sample file, so you'll need to modify this for your own network. And I have a sample file you can download on the article on the DronebotWorkshop.com website that you can modify for your own use. Now, what you'll need to modify is as follows. The first line that says country. Mine I've got set to CA because I live in Canada. If you lived in the United States, you would use US. Otherwise, you would use the two-letter code corresponding to the country in which you reside. Then on the network section, you will need to fill in the two items here, SSID, and this will be the ID of your network, otherwise known as the network name, perhaps. And then the PSK is your password, and so the password that you use to log into your Wi-Fi network needs to be inserted here. Now keep in mind that both the SSID and the password need to be surrounded by double quotes, and that everything, of course, in this file is going to appear in plain text. So this file actually is a small security risk if it got into the wrong hands because it contains both your Wi-Fi ID and password. So be careful what you do with this. Once you have your file created, you're going to need to load it onto the micro SD card. Now, if you've already done what I did and booted up the micro SD card without this file, then I'm afraid you've ruined it. You're going to have to reflash the card because this needs to be a brand new card. Once you get the brand new card flashed, put it into your computer and look for the boot partition. There are actually two partitions on the card. Now, if you're in Windows, the boot partition is probably the only one that'll display, but in Linux, you can actually see both partitions. In this case, the boot partition is the one here that says it is the 21 megabyte volume. And these are the files that you should find in a boot partition. Now, these files will vary for different models of the Raspberry Pi. This is the Raspberry Pi build for the Raspberry Pi Zero I'm using. Take the file that you created and copy it and paste it into here. Now after this, you can eject the card and insert it back into your Raspberry Pi Zero, and I'm going to do that right now. So let's boot up our Raspberry Pi Zero with the new configuration file we've just made. And as you can see, it's a little bit different than the original time we tried to boot without the config file. And there we go. We have an IP address right now for our Raspberry Pi Zero. So it has actually found our Wi-Fi network and connected to it. And in this case, assigned an IP address of 192.168.1.106, which of course I will eventually change to a static IP address. But this shows you how you can boot up a Raspberry Pi Zero or any Raspberry Pi using only Wi-Fi. Now let's take a look at what we're actually getting as a picture from this thing. So here's the image from my Raspberry Pi Zero camera. As you can see, it's similar to the image from the Raspberry Pi 3 camera because the camera is sitting right beside the other camera, and it seems to work quite well. Now once again, I'm going to want to go in here and change this to be a static IP address. So I'm going to put the advanced settings on. Go down to Network, and go to Configuration. Notice that the wireless network properties are already filled in, and the wireless network key is not displayed. And I'm going to make this 1.81 just so it appears right next to the other camera I have. You can use any addresses you want for your camera, but I suggest you put them all in the same local neighborhood, so to speak. It just makes it easier to keep track of them. And I'll apply that. And yes, it will reboot the system. And once it's rebooted, I will have a new IP address for my Raspberry Pi Zero camera, the same way I did for the Raspberry Pi 3 camera. So now that you've seen how motionEyeOS can be installed on both a Raspberry Pi 3 and a Raspberry Pi Zero W, it's time to take a look at some of the more advanced things that we can do with this product. So without further ado, let's go ahead and do that. So now I have two Raspberry Pi cameras hooked up, my Pi Zero camera and my Raspberry Pi 3 camera. And as you can see on the screen, I've got two separate tabs right now. At 1.80, I've got my Raspberry Pi 3 camera, and 1.81 is the new address for my Raspberry Pi Zero camera. And of course they're displaying similar pictures because the cameras themselves are only a couple of centimeters apart, but these could very easily be in different rooms and I'd achieve the same results. Now I'm on the Raspberry Pi 3 camera right now, and what I want to do is display both of the cameras on the same screen, because it's going to get a little inconvenient to go flipping between all these different tabs, especially if I get a number of cameras there. So I'm logged in as admin right now, and I'm going to go into settings. At the top here, it says Camera 1. Click on that and add a camera. Now it's going to ask the camera type. There are a number of different types of cameras that are supported. I want a remote motion eye camera. And then I'm going to need the URL of the camera. And I can get that just from here. I'll put that in. And I'm going to pick Camera 1 because Camera 1 is the name of the first camera also on my remote camera. You can actually attach multiple cameras to motionEyeOS because you can also use the USB ports to attach webcams. And as I'll show you in a bit, you can name the cameras so that they're more suitable. You can name them for the rooms they're in, for example. But right now this is okay. I'll hit OK. And there we go. I've got both cameras now on the same screen. And so you can continue to do that, to add as many motionEyeOS cameras as you wish. Now bear in mind that the Raspberry Pi that is hosting this right now is my Raspberry Pi 3, and it's now actually hosting a streaming service for both cameras. And so if you're going to add a lot of cameras, you probably want to use something like a Pi 3, which has a reasonable amount of power, because the Raspberry Pi Zero may get a little overloaded when you try to load 3 or 4 cameras onto it. But as you can see, this seems to work very well. So now let's customize our motionEyeOS a bit. Now again, I'm on the screen that's connected to my Raspberry Pi 3, and I'm displaying both the Pi 3 over here and the Pi Zero camera, but they're both named Camera 1, and that's a bit confusing. You can also administrate both cameras over here with the drop down, but again, with them both called Camera 1, that's going to be a bit on the confusing side. So let's go down here where you go to Video Device. You can set up the camera name. I'm going to set it as Pi 3 Cam, and I'll apply that. And now my camera is named Pi 3 Cam, and that's a little easier to see. Let's just close this over here. Now when I go here, I can now see that I've got Pi 3 Cam and Camera 1. Of course, you could name these for the rooms that you happen to have the cameras in. That would probably make a lot more sense. Now I'll show you a few other configuration things you can do here. If you scroll down over here, you've got two settings here, one for still images and one for movies. By default, these are off, but as soon as you open them up, they'll come on. And this basically gives you the format for the file name, which has the year, month, day, hour, minute, and second in the file name. You can change that if you wish. The image quality, the format of the movie that you'd like to use. You have a number of different ones, MP4, etc. The movie quality, the recording mode being motion triggered. You can also set this for continuous recording. On the pictures, you can set this for motion triggered for only one picture. Interval snapshot, so it can take a snapshot of the preset interval. Take pictures of every frame, which is going to take a lot of memory. Or manual, and what manual is you'll notice that there's a little icon on the bottom over here now that I've activated my still images that allows me to take a snapshot at any time I want to. And here are some of the parameters for the motion detection itself. By default, it's already set on. You can set some of these parameters for light change, for frame change, etc. and kind of customize it to motion in your room. This would actually be a good setting if you have a room that has something that moves a lot. Let's say some drapes that tend to rustle when your heater comes on or something. This will allow you to eliminate false triggers and such, so you can do that. Now, motion notifications has a number of options as well. You can send an email if you wish, and you can turn that on, and then you basically set up an email address, the SMTP server you want to bounce this off of, etc. I'm not going to set this up on mine. You can call a webhook, run a command, or end a command whenever you get motion. The working schedule allows you to set a schedule for when the camera is on. You can have it on every day of the week, or you can have it off, etc. I'm not going to schedule mine, so by doing that, by default, the camera's on. At any rate, I'll apply the changes I've made. And we'll close the config screen for a moment and take a look at the cameras. Now, once again, if you see my two cameras over here, you'll notice I got camera 1 and the Pi 3 cam over here. The Pi 3 cam, I'll go into this over here. All of them have the thing to toggle the full screen. By the way, the fact it just turned red means it just took some pictures because it was triggered by motion. So this allows you to take your camera full screen. You can take it back from there. Now this allows you to open the picture browser. And the picture browser will show me all the snapshots I've taken by the Pi 3 cam. Now I've taken quite a few of them already. I've taken 664 pictures in the short time that I've had this up. And so you can delete the pictures, you can delete them all, you can download the pictures if you wish. And the same goes for the movies as well. If you click here, you get the movie browser. And here are some of the movies that I've taken with the camera. So I can delete it, download it, I can even click on it, and if I wish to, I can play my movie. And there's a very exciting movie for you to watch. But they're all there. Now these are currently being stored on the micro SD card, which is not too bad. I mean, with a 16 gig micro SD card, I've got quite a bit of space to store it. But there are even options under the file settings down here where you can store the movies on another location if you wish. Under file storage here, you can go through. Right now it's custom path over here on the local drive, and it's used a very small bit of the 14.3 gigabytes I have left. But you can also choose a network share if you wish, and so if you have a place on your network you want to dump the movies, you can do that. So as you can see, motionEyeOS gives you a very versatile interface for managing one or more cameras. Alright, well this about wraps it up for our look at motionEyeOS. As you can see, this is a very powerful yet simple to use system that you can put to use with any Raspberry Pi as well as a number of other microcomputer boards. And you can use this to build a custom surveillance system for either your home or your business. Now if you wish, you could open up your router to allow this to be viewed from outside your home and business, but if you do that, be very careful on how you do it, because anytime you open up your router to the outside world, you're potentially exposing yourself to all sorts of threats. So it's a trade-off between security and convenience, so you'll have to make that decision on your own. Now I hope you enjoyed this video, and if you haven't already, please subscribe to the channel. I would very much appreciate that, and that would let you know when I make new videos for you. If you'd like to have some suggestions and inputs on what videos I make, the best way of doing that is to join my newsletter, and you will find a link to that below this video, as well as on the DronebotWorkshop.com website, where you'll find an article that accompanies this video that'll give you all the details you need to know about motionEyeOS, as well as a number of other Raspberry Pi projects. So until next time, please take care of yourself, and I hope to see you again very soon here in the workshop. Goodbye for now.